Let's take a look on this problem 14 under the section time, velocity, and speed from OpenStax College Physics. Okay, so we have here a football quarterback runs 15 meters straight down the playing field in 2.50 seconds. So let us assume that it starts from here. Starting position is here and is running downwards, okay? I mean, let's assume that this is the down position, okay? For what? 15 meters. Okay, so this must be here is that's 15 meters, and the time during it took him 2.50 seconds to run to this point. Okay, down 15 meters. However, he is then hit and pushed 3 meters straight backwards because of course somebody must have hit him. Um, so the quarterback is now in here. Okay, let me just move it instead of directly drawing that there. I think it's a lot better if we could try to sketch it somewhere here. Okay, meaning this is now the new position. Okay, it's here. So that's what that is a 3 meters. Okay, I'll just write it here at the side, 3 meters. Okay, and then he breaks the tackle and runs straight forward another 21 meters in 5.20 seconds. By the way, let me just write here the time took it, 1.75 seconds. Okay, and then now again he was able to free himself, and let us see here. Let me draw a line, and what? Able to move forward again, I mean down for 21 meters. Okay, here. Shall we say the 21 meters here at that position? Okay, so this one, so starting from there to here, that's 21 meters. And the time for that is 5.20 seconds. Okay, so let us recap the movement. The quarterback is moving downward, down the field um, for 15 meters for 2.50 seconds, but it was hit and pushed back 3 meters for a period of 1.75 seconds. However, he was able to break free from the tackle and then um, runs again down the field, or I mean forward, another 21 meters for 5.20 seconds. So we are asked here to calculate the average velocity for the three intervals, okay? Of course, this will be the what? This is the first interval, and then we have the second time interval, and the third time interval, okay? So let us see. So first time interval. So what is the average velocity there? So let's just call that v1. Okay, the average velocity will be it's able to travel 15 meters. It's just what change in position 15 meters. Okay, and a period of 2.50 seconds. Okay, we can call we could make it as a positive what we can then have a base like downward is positive, so meaning this could be a what a plus 15 over 2.50. So what is that? 15 divided by 2.50. Okay, it's 6 meters per second. So in average velocity during that time, the first phase, the first time interval is 6 meters per second. The positive means it's what? It's downward. Okay, we are assuming here that the positive means downward. Okay, for the second time interval, of course, this one will be pushed back. So we're expecting a negative velocity here interval. So V2 will be what? Okay, is able to what? Is moving opposite to our assumed positive direction. So 3 meters, we'll put a negative there. The negative sign simply indicates that it's moving opposite to the positive direction. 3 meters there, going there. So it will be negative 3 meters divided by the time, which is 1.75 seconds. So the average velocity during that time interval when he was tackled, 3 divided by 1.75, that is equal to 1.714. Okay, negative 1.714 meter per second. This is, if it is downward, well, we can just call it upward, okay, meaning based on our sketch, okay, meaning up there. So meaning during this time, second time interval is moving. By the way, the negative simply means it's upward. It's opposite to the our assumed positive. You don't really need to write this one. You don't need to write that one or this one. A positive 6 means it's downward. A negative means it's moving upward. And lastly, for the third time interval, okay, again we are expecting the velocity to be positive because he's now again moving down the playing field. So we'll have here v3. Let's call here the v3 average velocity is equal to able to travel 21 meters positive because it's moving. This change in position is downward, the one that we assume positive, over 5.20 seconds. Okay, so that's what 21 divided by 5.20, that will be 4.039. 4.039 positive meters per second. Okay, so for part B, for the entire motion, meaning what is the what? For part B, we're being asked here, what is the V average for the entire motion? Meaning if we consider the whole motion. Now, note that in this case, when we talk about now the entire motion, we talk about change in position, okay, displacement over the total time. Meaning we talk about total time. A total time that this changes happen is what? 2.50 plus 1.75 plus 5.20. What is that? 2.50 plus 1.75 plus 5.20. Okay, that will be 9.45 seconds. A total time of 9.45 seconds. And during that time, the change in position starts from here, ends here. So this will be what? 15, then moving there by 3, so now 12, moving by 21. That will be 12 plus 21. What's that? 12 plus 21. Oh, that's 33. Okay. So meaning all in all, the quarterback was able to move 33 meters down the field during that time interval. Again, 15 meters, moving back by 3, so now at 12, then moving forward again by 21. So total displacement, I mean, is 33 plus 33. Okay, so if we compute that, 33 divided by 9.45, okay, we are getting a what? 3.49 average velocity of 3.49 meter per second positive. Okay, and note here that we don't just simply what average this one, meaning the individual average velocity does not really account into the total average velocity. Okay, and note that average velocity only what look into the displacement over that time interval divided by time. Okay,